Let's talk about a silent guardian you rely on, literally every single second. It's a device that reacts in milliseconds, a true silent guardian of our entire power grid. Yep, it's called a vacuum circuit breaker, or VCB. And its success? It all comes down to one tiny measurement. And everything depends on this tiny space inside, known as the contact gap. So, first up is the contact gap itself. If it's too small, electricity just arcs right across. That's a fail. Then you've got the stroke. That's the total distance the contact moves. It's all about speed and force. And finally, contact wipe. Think of it as the spring pressure that makes a really solid connection. For a typical 12 kV breaker, we're talking about just a few millimeters. That's it. It's that precise. Okay, so what's really fascinating is the VCB's two different lives, one in the factory and one out in the field. And this chart really shows that divide. Some things are set once at the factory, and that's it. You don't touch them. So in the field, a tech's job is really to verify, not adjust. Here's how they check that gap. They'll also check the contact resistance. You want it below 80 microohms for a nice, cool connection. Then there's the closing time. It has to be lightning fast, right between 40 and 70 milliseconds. But the opening time? That's got to be even faster. We're talking 20 to 40 milliseconds to stop a disaster. But here's the thing. Every single time it operates, the contacts erode. This changes everything. So when it's brand new, a breaker's measurements are perfect. This is our baseline. But as erosion happens, those numbers get worse. The wipe disappears and resistance climbs. This is the danger zone. This is why knowing when to stop is so critical. There are some warning signs that are total red flags. You see any of these? That's not a field fix. It's a return to factory situation. No question. And this boundary is what prevents dangerous shortcuts and ensures reliability. It's absolutely key. So why does any of this matter to you? Simple. This hidden precision is literally what keeps your lights on. It kind of makes you wonder, right? What other invisible, hyper-precise systems are out there keeping our world running?